In this video, we are going to look at how to find the refractive index of water using traveling microscope. Next, let us look at what are the materials required.
So we are going to need a paper clip, pieces of thermocol, beaker, and bottled water because we need to find the refractive index of water here in this experiment. Then lastly, the traveling microscope. The traveling microscope has lots of parts, but for this experiment I'm going to narrow it down to few important parts, starting with the eyepiece that you see here. This is through which we look, and the objective lens which focuses the image, and both of them are controlled by this knob here. We also have the horizontal main scale which is controlled by this knob here. We can adjust the screw so that we can turn the microscope, move the microscope to right or towards the left. But for this experiment we are mostly going to use the scale. This is the vertical scale which is controlled by this screw here. This is the vertical adjustment rod. Using this we can move the microscope down or up. Before starting the experiment, we have to look at how to find the least count of the traveling microscope. We have to divide the value of one division in the main scale divided by number of vernier scale division. And then finally we get the value 0.001 centimeter. That is the least count. Now for the experiment setup, we have to place the microscope vertically downwards, pointing towards the beaker. And at the bottom, if you look carefully, we are going to place the paper clip just like this. Then we have to use the adjustment screw to adjust this image just like this. Then take the reading from the vertical scale. We have to take number of coinciding vernier scale as well as the main scale reading. And this is the observation table that we are going to use for this experiment. See here, this is what we are going to use for the first experiment. First, before inserting, we have to know what to insert, how to read. So the final reading is always main scale reading plus the product of vernier scale coinciding and the least count. So after the first experiment, we have to record like this: 4.6 plus 49 times 0.001. Then after that, the next step involves pouring of water on top of the pin and trying to get the sharp image like this. Just like the first step, we have to take the reading of the main scale as well as the vernier scale coinciding. And then we have to insert this in the observation table in column B. Then in the next step, we have to sprinkle some pieces of thermocol and try to get the sharp image like this. And again, we have to record the same thing, main scale reading and vernier scale coinciding, as we can see here. After this one, we have to start calculating, and the formula to find the real depth first is C minus A, and then the second one, apparent depth, we do it by C minus B. Then we can find the refractive index of water by using the formula real depth divided by apparent depth, that is C minus A divided by C minus B. Here we got 1.4348. Then we should remember to restart the same experiment for 2 more times to get more exact values.